Perhaps I was a little bit naive in agreeing so readily to Sabina's request to come out here and following up with all the great imagery and also the great work that's being done actually in the natural environment side, more importantly. But I do hope that through what will be portrayed in the presentation will come across is the built environment and the natural environment are intrinsically linked together. You cannot separate one from the other. And they're both very important in ultimately how our ecosystem, our whole ecosystem, functions. Just a little bit of background on ourselves. We are an architecture firm. I happen to be an engineer, so I do apologize in advance. We are based out of Chicago. We're roughly over 100 employees. And we've worked on a number of key projects. The key project I'll talk about today is the Masdar Headquarters. However, prior to forming our firm, approximately about 3 years ago, we were involved in some other key projects with another firm, which I won't mention. First item that I wanted to leave you with, idea or concept, was that life imitates art far more than art imitates life. I think sometimes we forget about the fact that we are products of our designed environment. We grow up in the environment and it just becomes natural to us, and we don't think about the fact that we grow up in a built environment, and we don't question it. And this is really the perfect slide to begin things off with, because actually before I was in the architecture industry, I worked actually at Shanghai General Motors. Then of course also GM is no stranger to the news these days. So this is actually an image from the 1939's New York World's Fair. And GM had a little bit of a predicament. They had a technology, the automobile, and they wanted to sell the technology. However, the majority of Americans at the time lived in urban cities, urban centers. So part of their job, their role, their marketing, was to actually sell this concept, this notion of suburbanization, to leave the city center and to seek new territories, new grounds. And you look at the models and, actually it doesn't look too dissimilar. Actually, it looks very similar to where I was a couple weeks ago, actually in Dubai. So these models are not only explicit to the United States, they're pervasive. They've been exported around the world. But you have to look at, effectively, this was the model of the day. So this was actually very radical and bold thinking. But of course, there are other implications, suburban sprawl. And you look at, for instance, this image here, a satellite image of Las Vegas in 1973 versus Las Vegas in 2000. When you do the math, an average American burns approximately 600 gallons a year, or about 22,000 kilowatt hours of energy, wasting just in commuting. They waste over 100 hours annually in their commute. And this also has other implications beyond just your commute. You look at urban decay. So you look at the home price. There was actually recently an article, I'm sure many have seen it, on the average home price in downtown Detroit being less than $20,000. So there are other implications, there are other costs, not simply just energy costs. And I threw this slide in. Actually, this was a slide I had in an older presentation. One time at the previous firm I was at, we gave a presentation in Beijing, and I sat next to a woman in Beijing, and she was explaining to me that they were testing out a new policy where if your license plate began at an odd number, you're allowed to drive Monday, Wednesday, Friday. If it began at an even number, you drive Tuesday, Thursday, and then they had a Saturday flex day. And cut down her commute time in half. So instead of commuting for an hour and a half, it was about 45 minutes. And so that got me thinking. So I asked her, where she lived and where she worked. And Beijing is kind of centered around these ring roads. And she really only lived about 17 kilometers away, not too far. But when you considered her office energy impact, it equated out to about 1 metric ton of carbon per year associated with her space in her office building. However, when you considered her commute, and that's 17 kilometers per day, and you took into account an average gas efficiency, it's 5 metric tons of carbon. So you've gone from essentially 1 metric ton of carbon to 6 metric tons of carbon when you take it on a commuter basis. But that's not the only impact. One also has to consider redundant function. The fact that our urban landform, the way we've developed, has instilled sprawl, we have not just one Walmart or two Walmarts, we have a multiplicity of Walmarts. And these serve essentially the same function, but economically, they make sense in the general construct of our own development. Now we take that and compound it with the fact that we had a perfect storm of technological innovations over 90 years ago. When you consider in 1922, Mies van der Rohe and the glass skyscraper in Berlin, and then Louis Carrier in 1922 also inventing mechanical refrigeration. And so I've always wondered if these guys have ever met. And what we were able to do is actually develop landform. We were able to develop buildings which didn't respond to their environmental context. So you look at, for instance, Heat Island costs Los Angeles $100 million per year. And then it makes you consider, well, what about healthcare? Just a half a degree C increase in temperature leads to 3% increase in smog formation. So they've done studies where they've concluded that cooling LA by 3 degrees C would be equivalent to taking all of the cars out of the airshed for an entire day. So we've been commissioned, actually we won an international competition 2 years ago to design the headquarters building for MASDAR in the Abu Dhabi Future Energy Corporation. And what's interesting about this project, there are a number of things which are interesting, but probably one of the first things that jumps out is that it's a car-free city. So there are no cars or vehicles into the city. It's also completely powered by renewable energy, and it has a significant reduction in waste, about a 90% reduction in waste. So it's really the first step in Abu Dhabi, and really the first step in any major hydrocarbon-producing economy to launch an initiative towards burgeoning a renewable energy future. As I mentioned, it's driven by the Abu Dhabi Future Energy Corporation, which is a subsidiary of the Mubadala Development Corporation. And really they have a threefold task, and that's to engender solutions towards energy security, climate change, and then ultimately sustainability and educational legacy. So one of the aspects of this city is that it will actually house the Masdar Institute of Science and Technology, which is a joint venture between Abu Dhabi and MIT. And ultimately, the intent is not only to think of the energy side of the equation, which as an engineer I have a tendency to do, but also to consider the quality of life and the health and the happiness which the city instills. So this idea of creating a very dense environment which also fosters collaboration and communication. This is what it looks like today. So maybe not the spinning image of health and happiness that you might initially believe, but it's very much a build it and they will come sort of philosophy. So you can see the lower corner here, that's a 10 megawatt power plant, and that will actually power the construction process for the entire development. The Masdar Institute Phase 1 is located there, and then we're slightly adjacent to that site. So we've been following an ISO 14001 framework where we've considered for sustainability management throughout the entire design process. So it's a very innovative design process where we've considered greenhouse gas, waste, resources, social, and economic implications. So for instance, every time we travel to Abu Dhabi, we track how far we travel, we track the type of airplane that we were on, those sort of elements to track essentially what our embodied carbon is in the design process. And that's probably only about 1% of the total carbon for the entire project. And then ultimately, what we've developed are key performance indicators. And essentially, these are the indicators which we track throughout the entire design process to ensure the performance of the building is meeting the original objectives in the competition. So this is what it looks like. There's been minor modifications. This was actually a competition submittal. But first thing that you notice is a overarching roof canopy, which actually serves to shade the building. And also it features, it's hard to get a sense of scale. That's actually over 3.5 football fields of photovoltaics, which are covering the building. And what that allows us to do is actually create a microclimate underneath and establish a roof garden in a climate which otherwise we would not be able to do. So this is just a diagram showing you that concept. Another element which I forgot to mention was the cones, which you can see the cone here in the lower left-hand corner. those are meant to serve a variety of issues. One of the aspects of building a city which is completely powered by renewable energy is that it limits you to a form factor of about 5 stories, and then you cover the remaining roofscape with photovoltaics, among other things. And so because of that, this is about a 1 million square foot building. We had a very deep lease span, so we needed to bring natural light into the space and reduce the energy. And so that's one of the elements, or one of the aspects of the integration of the cones. What's also kind of interesting is when you start to design in response to your climate, your architecture actually starts to resemble architecture, historic architecture, contextual architecture. So for instance, you look at the souk here in Marrakesh. One of the other aspects about essentially burgeoning sustainability in this development was it's a car-free city. There are PRTs, which are essentially, you can consider them as horizontal elevatoring. So they're personal rapid transport systems. So because there are no cars, the entire city actually sits on a plinth, a podium, and you go in and you type in, it's very futuristic, you type in the location where you want to go and it routes out the fastest location to get from point A to point B. It takes you there, and then you come up from essentially the podium space. But another key element is just creating walkable communities, which is absolutely essential to also improve the environment, because today, in fact, I think it's about 115 degrees Fahrenheit there and about 60% relative humidity. So that's another key element for including the cones, including the water features, is that we're actually using them to establish this microclimate. In fact, the water features are integrated with the mechanical system. So because of the humidity, we extract an incredible amount of condensate or condensation out of the air. And that condensation is cool. So then we feed that to actually the water features within the cone spaces to further create the microclimate and cool the space. So we're actually able to maintain temperatures 12 degrees C cooler than would otherwise be experienced. And that's just a rendering, a visualization, as you can see down in the cone. And here is a visualization looking at, actually, this is an old visualization. That is the form has actually changed quite a bit at the top here. We've actually included citrus trees, fruit-bearing trees, and the aspect is that we're actually generating local produce actually for the building. Aerodynamics, also the other impact is essentially the cones are actually improving the microclimate and actually pulling air through the building. The entire lower portion of the building is essentially a continuation of the street. And again, kind of this reference to contextual design, as you can see there. So what's interesting, too, is buildings themselves serve as ecosystems, as they also serve as an element within the greater ecosystem in which they're located in. And so early on in the design process, the client asked us to do a cost-benefit study for the wind cone. And at first we chuckled and said, well, you know, it's an iconic part of the building. It is the building to a certain extent. It's not an engineering system per se. It's architecture, so how do you do a cost-benefit study? Well, being good consultants that we are, we ultimately did it. And so in the process, when we first started, we looked at the initial scope, and we just simply considered the cone. And we considered the daylight energy savings with the cone. It was about a 17-year payback in terms of carbon and a financial payback of about 32 years. And that's offsetting the cost of the steel that goes in and the glass that goes into that structure. But then we expanded that scope and said, well, you know, ultimately that cone is also supporting the trellis, and the trellis is integrating photovoltaics. Well, one of the great aspects of integrating photovoltaics above the roof plane is that we kept them at a lower temperature. Keeping them at a lower temperature increased the efficiency, so we got more power. So when we included the cost of the trellis, we included the cost of the PV, our carbon payback went from 17 years to 5 years, and our financial payback period went from 30 plus years down to 19 years. Well, then we expanded it even further and said, well, ultimately, by shading that roof plane and creating a landscaped roof garden, we're able to increase the rental premium because that becomes premium office space as opposed to just standard office space. And when you do that, the carbon payback remained the same. However, the financial payback fell even further. And if you were to include the productivity savings, which we didn't, ultimately your payback period would be negligible. In fact, it could be 0. One of the other elements that we've done is we've actually tracked all of the embodied carbon with the building. So we actually have a dynamic virtual model which tracks everything from the concrete to the steel to the aluminum. Everything included in the building is tracked and quantified. And those are carbon variables explicitly related to Abu Dhabi. So we take into account, for instance, shipment and what have you. Another aspect of the building is the intelligent infrastructure. We get carried up in engineering systems or the material embodied carbon, but also behavioral change and the opportunity for behavioral change to reduce the overall carbon emissions. So the building is very intelligent. It will display information such as how much water is being consumed, how much energy is being consumed, letting users know. I think the intent is, it's kind of interesting because you do get into this social realm of what's too much information, what's too little information. Do you want ultimately the opportunity to look at the guy sitting next to you and say, oh, well, you're using twice as much water as I am. You know, it gets into privacy issues and what have you. But, you know, those are issues that I think everyone will start to grapple with, not simply this city, which is an experiment to a certain extent, but, you know, the United States, Chicago, for instance. So we've also tracked essentially the total energy performance through all of the strategies which have been included. And I think it's really important to stress that no building is an island, that essentially this city or this building ties into the central district systems. And so the building itself is actually, when you consider the site, 137% energy positive. And then 34% of that energy goes to offset the central utilities, and essentially there's an economy of scale with those central utilities. So the building itself, total energy consumption is 3% energy positive. And really this is kind of the punchline of the whole presentation in that there's been some talk on zero energy buildings. There's a few zero energy buildings that are actually being developed here in the United States. But when you consider total carbon flows for a built structure, you have operation, you have maintenance, you have other energies which go into the overall daily use of that building. And so it's not really until you get into a positive energy situation that those trends start to diverge and that you actually start to become part of the solution rather than part of the problem. And so why I think this is so important is that when you look at the carbon cost abatement curves, building efficiency is one of the most cost-effective ways to reduce carbon emissions. And as I like to say, you're either at the dinner table or you're on the menu. And so we like to be very proactive in understanding new legislation, and trying to structure it in such a way that it does support energy efficiency in both new buildings and as existing buildings. And so what does that translate to? The energy that we offset through carbon emission reduction is essentially about 5,100 metric tons of carbon per year. And so typically I say that, well, that's enough energy to circumnavigate the world in a 747 850 times. So feel free to come to Chicago and visit us, but you're already here. So if you have some time and you want to visit our office, you're more than welcome to stop by. We're in downtown Chicago. So thank you.